Good morning, everyone. Welcome to another exciting lab period here. Another video that you get to see. Today, we are doing Lesson 5 in Unit 8, which is Series and Parallel Circuits. And we're going to be building off of Lesson 3. If any of you got the chance to do that, creating a circuit, we're going to be building off of that. We're actually going to use that circuit that we created, and I'll show you how we did that in case you weren't able to do so, and build off of that, making series circuits and parallel circuits and seeing the difference between them up close and personal and in real life. So what I'm going to do right now, I'm going to show you my materials. All right, what I have is my copper wiring. You can see I've unsheathed the end. I'll show you how I did that in a little bit. But I've already unsheathed it because it's a little difficult. It takes some time. I figured I'd just take care of it. I have my two D-cell batteries. I have my battery holder, and you can see they have the wires already attached. I have my sockets for the lights. I obviously have my two light bulbs that we're going to be using. And then I have my block of wood, my paper clips, my thumbtacks to hold the switch in place, and I've a metal piece where you can get that out of your magnets. That there's a small metal piece there that works just fine for creating our switch. Okay, so that's what I have. As far as the pages we have for our lesson, it is on page 361 in our student pages, 361 through 365 is where we're going to be doing our answers. So we will get to that in just a second as we get started, and we'll see you back here. As soon as you get your book out to page 361, we will move on. Okay, now working on our second set. Now we're going to set up our series circuit to start with. All right, first I'm going to show you how I unsheathed these and then get it set up a bit. How I've unsheathed this is I take a wire stripper, much like the one you see right here. I kind of just go down there, just get on the rubber, and pull it right off. And I actually pulled it off too much there. So let's try this again. You got to be real careful because you can cut the wires rather easily. You can see they're a little frayed, and what I like to do is I twist them together to make them a little bit easier to use. Or to work with, okay? If you twist them together, you can wet your fingers just slightly. Twist them together, it makes it easier. They're not all frayed out and going crazy like your hair in the morning, right? Well, not mine, because I really don't have a whole lot to get too frayed and frizzy, but you know what I'm saying. All right, then I'm going to take here from this side, I'm going to take my paper clip, and I'm going to put it into the metal, and I'm going to wrap this around. I'm going to wrap the metal, exposed metal that I've sheathed off around. And why do I do this? Why do I put this around the paper clip? Well, remember what we have said, metal is a good conductor of electricity, and I want to wrap it to keep it tight so that as the electrons get flow from here into the paper clip, they will still go through. It'll create a situation where we can use this as a switch. But remember, it's because the metal is a conductor of electricity. Now, this side I've already done, and I'll show you why. It's a little bit, these wires are a bit thicker, and it's a little bit tougher to bend these. So what I've already done is I've bent it around and put it onto my paper clip. And the next step in this series is what I'm going to do is I'm going to attach it to my receptor here, and I'm going to get it underneath the there's a screw here, metal screw to hold it in place. And what you need, it says a Phillips head screwdriver. Be honest, you need, if it's the same stuff I have, you need a flathead. So I put that onto the receptor, and then I just tighten it up. And you can see that most of this receptor is plastic, white plastic. But where these wires come into place, you can see it's metal. Again, metal is a good conductor of electricity. That's why we use it. Okay, so now I'm going to put this, and I'm going to take this wire, and this is bendable, not incredibly pliable, but easy to do. And I want to keep it about a 1/2 inch apart from this piece right here. So we can do that. Well, I'm going to get it up so I can actually use it. All right, and if you can test it, well, as long as that metal bar goes across like that, you can use it as a switch. Taking this off undoes the switch. Let's move it back here so I got some space. All right, so I gotta fix this because that decided to go off. All right, there we go. All right. You got to be real careful with these wires sometimes because they are very temperamental, is a good word, I would say. All right, let's do it this way. You can play with this to make sure it works, see what works best for you. All right, what I'm going to do is I'm going to put my battery in here. My battery on this side. Now I have my D-cell batteries. Now, obviously, with 2 batteries, I increase my power that much more, right? I'm going to put my light bulb right into here. Now we're going to test it. Now, this pulled out, so we're going to see. It's going to be tough, so let's see. I'm going to check it. See, now I just got a loose wire, but if I fix it there, oh, look at that. I have a light. I have created a switch and I've created light. Here's my switch. If I take it off or move it just slightly, boom, I can just fix my little wire to fix it up. And I have a switch. So what I have done, I have now created a closed circuit by putting this metal bar across like a switch. Okay? There's only one light, so I don't have a series or parallel at this point. I just have a circuit. All right? I've created a closed circuit. All right? That is step 1. Now we're going to come back and move on to the next step, which is going to be to build a series out of it. So we'll be back in just a sec to join. All right, as you can see, we've come back and I've changed things up a little bit. What I have right now is set up a series circuit. And at this point right here, I'm going to try and move these things around so they're sitting a little bit better. At this point right here, I have what we call it open circuit, right? I have no power going throughout. There's no power to any of the lights. Right? There's no power to any of the lights, mainly because I have an open area, an open circuit here that's not allowing electrons to flow around. So once I do this, I have it set up, and I'm going to put my metal bar across, and I got to get it so because it can be a little temperamental here. That's because of the way it sits. And look at that. Now I have a setup here where I have a closed circuit. I've put my switch down. I've closed the circuit. Electrons are able to flow through. And look at this. I got light. We have light. Okay, so I have light in my resistors. The electrons have passed through each resistor and gone through and circulated through a closed circuit. All right. What I do see differently is that if you look at the lights, and I'm sorry, I want to make sure I get that other light in there. Oh, there we go. All right. If you look at the lights, when I put a second resistor on there, what happened to the illumination factor? What happened to the illumination factor? Okay. And you know, the one question: how could I make it? How could I make it brighter? What could I do to make this brighter? All right, and back again, and here we have our final setup. All right, we have our parallel circuits. And what you notice about the parallel circuits is now at each of these, at the receptor here at this first light, I have essentially 2 wires coming in, and a wire coming in and a wire coming out. So 2 wires are attached to one receptor. One from the power source comes across to here, and then one goes to the second light. All right, so we've made a double parallel. So what's going to happen is you'll see is because I have more wire, what do you notice about the light right away? Because I have more connections to it, All right, I allow more power to get through to each one. Okay, and it gives me a bit of a brighter look. Right, I get a little bit of a brighter bulb. Now the difference here is, now watch, I'm not gonna, this can be temperamental sometimes, so you gotta just play with it. I'm gonna undo this light bulb. Okay, you can see I've taken it out, but what happens to this one? Oh, you can't even see it. There you go. Hello. All right, this bulb is still on. All right, I've taken the other one out. I have it here in my hand. There's no power going through here. This, if I would look at it this way, if you can follow my finger, this cord from the power source, this cord here, comes across here, and this is an open circuit. Sorry, this can be temperamental. This is an open circuit here to here, but because I've added that second wire, I made it a parallel circuit. This wire still is an open or a closed circuit all the way around to here. There's still a closed circuit. Right? With this, I had to loop it a little bit, but I loop it around and then it comes out here. That's still a closed circuit. So even though this bulb has gone out, the rest of them will stay on. I can just plug a new light bulb in there, and guess what? Now you can see the power does shift a little bit. It makes it a little bit less bright, illuminate a little bit less, but it still has power to it. Just like these, right? Perfect example of a parallel circuit is Christmas lights or holiday lights right here. You can see all the wires in here going to each light. I've paralleled them. I've given myself a closed circuit even if one breaks. Okay? So that's your difference. There's your difference between the parallel circuit and a series circuit. I hope you enjoyed this lab. All right, at least got to see how these circuits work in real life and see where the electrons flow or how the electrons flow through the circuit. What you need to do now, page 364 in your student pages. All right, you have 5 questions. You're going to need to answer those 5 questions on page 364. Best thing to do them now. Guess what? You're going to have to do them in Juno tomorrow. So do them now. You'll have it all set up. Your assignment for tomorrow in Juno will be these 5 questions that we're going to grade for you. So you can get it done now. You can get it done early. All you have to do tomorrow during class is type it in. You'll be good to go. All right? So have a great day. Have a great afternoon. Tell your parents about parallel and series circuits. Make sure you have parallel circuits in your house. Now you're on your way to becoming an electrician. All right? No, just kidding. Just take it a step at a time. I hope you enjoyed it, and have a great afternoon. Bye.